Okay, so this morning we are going to talk about the Spark runner and, well, what's the current status in Beam. And I'm really glad to introduce this to do this talk because the Spark runner had a huge amount of things going on in the last year. So let's see what happened. And now, let me introduce myself. I'm Ismael Mejia, software engineer at Talent. I'm paid to contribute to open source projects, Beam, Abro, and other projects. And if you have done some PRs around the Spark runner or some I/O connectors, you probably know me. I don't know you, so it would be nice to meet. And don't hate me if I was evil in the PR review. And let me introduce David, and let's go.
Okay. Hi, I'm David. I'm a lead engineer for a Cessna search engine. And I'm also an Apache Beam committer. Today, we're going to talk about the Spark runner. Like, who knows Spark? I'm wondering, like, there are some people that didn't raise the hand. Was that intentional? Or okay, so why Spark? Like, Spark is super popular. Like, we can judge it like by the stars on GitHub, I guess. Like they have like 23,000 stars and like 20,000 forks, which is like really, really big number. It can run almost anywhere. Like it supports all kind of resource managers you can find. It supports Yarn, Mesos, Kubernetes. Also, there are some like as a service offerings where you just like submit your job and it runs it for you. Okay, this talk is going to be divided into 3 sections because right now there are basically 3 Spark runners in Beam. The first one is a legacy runner, which I will talk about, and then Ismail will take over and he will cover a portable runner, which is built on top of the legacy one, and structured streaming runner, which is the latest effort we do on Spark. Okay, so the legacy Spark runner. Legacy is probably not the correct word. It should be called production-ready runner. But yeah, all the production-ready things are really boring, so we just call it legacy. For those of you familiar with Spark, there are currently 4 APIs. Like the oldest one is RDD and dstream API. RDD is for batch and dstream is for streaming. Then I think starting like Spark 2.x, they introduced a dataset and data frame API. It's basically the same thing you could have seen yesterday in Beamstalks. Those are just like data sets with schemas, and data frame is just like a generic schema. So the legacy runner is built on top of RDD and dstream, so we basically need to do separate translations for both batch and streaming, which like introduces some development overhead, but yeah, I think it's fine. So a little bit of history. Spark runner started in 2015 from a donation made by Cloudera. Then later in 2015, PayPal guys really put quite of an effort to make streaming work on Spark, and it actually works pretty good. And they also did a support like for metrics and all other features that were missing in the runner. Then in late 2016, we were running our Spark 1.6. Like that version had a lot of problems, but it was pretty stable, I'd say. In 2018, we moved to Spark 2.x, which is basically like if you have ever struggled with Spark, it's basically like going from out-of-memory errors on the driver side to getting out-of-memory errors on executor. That's probably the biggest difference. And the performance impact is really huge. They made a lot of fixes in Spark 2.x. And then in 2018, we focused a lot on performance tuning, and this is the part which I'm going to talk about today. So I'll just cover some of the issues we were facing. Maybe those ideas can be reused by other runners. I don't know, maybe you find it useful. Okay, so first, really big issue we had when we were trying to run some really large-scale jobs on top of Spark was that if you do a group by key, all the values for a single key must fit in memory. This usually doesn't bother you, but there are some use cases where you really need it. For example, when you're building H files for bulk load to HBase, they tend to be really huge, and you just need to group it by your region ID. So there is no way those would ever fit in memory. So what can, is anyone familiar with those two Spark calls, like group by key and reduce by key? What is the difference? Does anyone know? Oh. Yeah, basically, if we would go back to the Beam world, it's the equivalent of group by key versus combine per key. Combine is very more efficient. For those of you who still don't know, if you take a look back to MapReduce, it's an equivalent if you used an in-memory combiner on the map side. Then you just shuffle way less data over the network, and it's way more efficient. The problem is that basically in Spark, group by key is implemented using combine by key. And they just use a list combiner. So anytime they see a new element for the key, they just append it to in-memory list. So at the end of the day, you just need to keep the whole list with all the values in memory, and yeah, that's not gonna fit in. Yeah, one interesting issue we encountered while implementing group by key, does anyone know what's wrong with this code? In Java, if you use arrays, their hash code implementation defaults to object identity hash code. So basically, you have no guarantee when those keys will end up after the shuffle, and it's something to be aware of. It's the same thing if you are using composite keys that contain enums, because enums basically have the same problem. Someone would say that hash code should default to ordinal value, but it doesn't. Okay, so what can we do? We can just go back into history and take an inspiration from MapReduce, and we can sort everything. So basically, if we sort the data set by key, we can do much better, but there are still an issues, because in Beam, you have this concept of windowing, and all the values you get for the key are windowed values. So if you're grouping them, basically if you, for example, have an hour worth of data, and you split it in fixed windows with 10-minute steps, it's still all the data goes to the single key, and you need to explode the windows and group them by windows on the reduce side, which is not really efficient. But you can do way better if you put a window into the key itself. Then you have like more finer-grained groupings of the keys, and then like only a single key and single value for the key at the time needs to fit in memory. If you just read it, you can just read it sequentially, and you see one key at the time, and you don't need to track the other keys you've seen before. Okay, so it will look something like this afterwards. Okay, that was one issue. We actually fixed this for group by key, but there is an ongoing issue that tries to solve the same thing for combine per key. It's gonna be fixed, I think, for the next version. But basically right now you have an in-memory combiner for every key which needs to hold values for every window for that key. So for example, if you're calculating some counters that like you want like counter for every minute for last year, it will be so many windows that needs to fit into single combiner that you would just run out of memory again. Then we really struggled with performance of combiner. We actually started profiling Spark, like I would say 6 months back, and we've seen like really terrible performance with combines, and we found out from the flame graphs. This one is like, for those of you not familiar with this tool, is generated by Babar, which is really great tool for profiling Spark made by Criteo. So if you're into Spark, you should definitely check it out. It's very useful. And we found out that with each element being added to the combiner, we need to like serialize the whole combiner and deserialize it again, which is like really, really inefficient if you add a lot of elements on the map side into a single combiner. So we introduced some kind of lazy combiner where you just like, where you keep the deserialized value and you serialize it once you have to shuffle the combiner over the network, because that's actually the only point where it needs to be serialized. So in pseudocode, it would look something like this. Then we really struggled with performance of site inputs. It was doing pretty good, like until site inputs grow really big, because we were using them for like those broadcasted hash joins where you take the data set from one side and you broadcast it to all the executors, and you just do in-memory lookups on map side. And in Beam, there is this site input reader interface, and with each call which happened for every element that we needed to look up, it kind of like took the binary representation of the site input, and it needed to like deserialize the whole site input with each call, which means like if you have, I don't know, serialized site input which is 1 GB in size, it's, yeah, the job is just not going to finish, or it's going to take really, really long time. So we basically introduced something, just a wrapper that can cache it for a particular window, which proved to be really useful, but still it didn't do the best job it could, because if you look like at how Spark executes tasks, you have an executor, and executor executes multiple tasks in parallel, and Spark works like it executes only one stage at a time, and all the tasks for that stage need the same site input. So if you had 4 tasks per executor, you still needed to hold like 4 of those cached site inputs in memory, which introduced like a lot of memory overhead, which was really unnecessary. So we kind of like work around this by using like static JVM wide weak hash map. It's actually using like Guava caches with weak keys, but it's basically a weak hash map. So is everyone familiar with these? Like, it's like once you lose a reference to a key, then like value from the map can be garbage collected. So this was like the only way we could keep track if anyone is still using those. Okay, then there was this migration of metrics to accumulators API version 2, which was recently introduced by Spark. The old API is basically just wrapped into this API in really, really inefficient fashion. So once we introduce this change, you can see this like performance gain that we got like just by changing the API. Like considering it's just a wrapper, it's very interesting that it had such an performance implication. Okay, so there are still like, it's production ready. We use it on really, really big scale, like hundreds of terabytes, but it still is not quite as good as it could be. Like, for example, if anything goes wrong in Spark, it usually gives you this like really generic exception, and you really have no idea what is going on unless you spend years debugging Spark and you already know what to look for. So this is like one thing to be aware of. Just like most of the exceptions are hidden under this fetch failed exception, which can basically mean anything from out of memory to unresponsive shuffle service, and it's really painful. Then one of the biggest issues we have right now, if you split the execution graph, for example, like if you have a P collection that has multiple consumers, then Spark needs to take this P collection and it needs to persist it on disk, and then it rereads it twice, which is really inefficient. For example, if you have, I don't know, a data set that is 10 terabytes in size and you want to split it, that one split would contain majority of data and other one would contain just like hundreds of megabytes, it will be really inefficient. Because just because of that, you would need to persist everything on disk. And there are, of course, other issues. Okay, so now I'll hand over to Ismail, and he will tell you something about the portable Spark runner that was introduced recently. Yeah.
Thank you. So, well, as you saw, well, the existing runner was really improved in the last months, and that's thanks to David and his team in Cessna. Well, the portability effort was going on Beam, and of course, a common question was, what is going to happen with the Spark? Will Spark have a portable runner or no? And just to remind you, that's the Beam vision. We want to support all kinds of languages that you can use to write your Beam model pipelines. And those are translated by different runners. Of course, in our case, we talk about Spark. So we can execute our code in every one of these runners. And that was easy to do because if you notice and the reality, was that 1 year ago, that was what happened. We have this translation from Java things into Java things. That was the old way we do. And that's the way we could target most of these runners because those are Java-based. But when we talk about Python or Go, we couldn't do that. Actually, it was supported by Dataflow, but that's a different story. So that's why we introduced the portability framework. And just to understand a little bit, this is how legacy runners work. So a user just writes his pipeline with, for example, Java, and then there is this translation phase in the runner where all the concepts of Beam, for example, a Pardue, becomes an rdd.map in the other side. And of course, there is some wrapping to have all the timestamps of all the elements and all the information for windowing and all this stuff. But basically, it's just Java to Java translation, which is relatively easy. However, for portability, this didn't work. So we needed a slightly more elaborate framework, let's say. And the idea here is that if you write your code, for example, in Python, but you want to execute this in a JVM-based system, well, we need to find a way to represent and isolate your execution. And this is what portability does. First, by introducing a generic multi-language representation of the pipeline. This now represented with protobuf. This is sent to the job server, and the job server starts this new translation, which in the end, what it does is to rely on a set of services that isolate the specific language environment. This is what we call the SDK harness. And those allow to invoke the native language execution. So this is pretty nice, but it implies that we have to change the runners to do so. And 1 year after, in 2018, at the end, the Flink runner really progressed on this. But again, we were in this point where, but Spark is not there. So this implies a new translation for Spark. And that's what happened with the portable Spark runner. So this is basically a new translation, but surprisingly, it's an easier one because now many tasks are passed, the responsibility of many of the tasks are passed to the SDK harness. And so that was a surprising feat, at least for me. There is also, we had the advantage that all the work that was done by the Flink guys, Max especially, and all the people involved in portability. And the idea was to reuse what we had with all the benefits that David presented with the portability stuff, and that's what happened. So far, it's still using just the RDD API, and it's batch only. And it's already in master, and it's going to be available with all the full feature set in the next release that will be coming soon, like probably in 1 or 2 weeks. So that's a great progress. I have to publicly recognize Kyle Weaver from Google, whose single man effort who did most of this. If you are a Googler, vote for him for promotion or bonus or whatever. Excellent work. And this so far is the capability matrix, that is this table that we use to follow the progress of the different features of Beam. So there you can see the transforms and if they are translated or no in each runner and in each mode. And as you can see, as I said, the portable Spark runner is batch only. But as you can see, we're pretty aligned with all the things that are already supported. This comparison is just with Flink because Flink is the most advanced runner in portability. So a part of this, another thing we did that was done was to introduce the validated runner suite, which is to evaluate the runner with the validated runner suite. And the validated runner suite is this set of tests that test that the runner is well implemented. And this kind of like has TCK in the case of Java. So all kind of weird cases are tested. What happens if I put an empty side input and I flatten with empty collections? All kind of weird stuff, but that makes the runners robust. Also, the new portable runner was integrated with the CI of Beam. So if any new change, for example, in Spark, in the old runner may affect this, we detect it. Everything is tested against both runners. And even changes in Python also now are tested against the new Spark portable runner, so that's cool. And of course, we support now Spark running Go pipelines, so that's also innovative, let's say. So what's next? Well, there are still some pending tasks. There is the pending tasks that are still missing for other runners, portable runners too. So support for custom window functions, splittable UFN, the things that are not done. But more important for the case of the portable Spark runner, well, support for streaming. This is the number of the ticket in case you want to check it out. Of course, and performance analysis for this portable runner has not been done, so introducing Nextmark, that is our performance regression test suite, would be a good idea. And improve the documentation too. Today, you can go to the web page of the Spark runner, and you will find the documentation on how to run a pipeline with the Spark runner, but that's all it is. We have to improve that. So now I'm going to talk about another runner. So this is the structured streaming runner. It's called like that so far. And you may ask yourself, why another runner? If we already have the old first runner and the portable runner, what's the reason to write this again? And there are many reasons, actually. One is to benefit of the unified API for batch and streaming that the Spark guys have. The second one is that this API is schema-based, so you have the schema information, and this schema may be useful to optimize pipelines, so this is one other thing. Other thing is with this API, they introduce what they call the continuous mode. So now in Spark, you can run without micro batches. You can run continuously. So for the Beam model, this is like a really important thing to have. And well, because they always announce that this is the future of the Spark APIs, and eventually they will deprecate and even remove the older APIs. And from the Beam point of view, one important thing is that we will have a single translation, not an RDD translation and a D-stream translation. So that's important. And definitely, it gives us a wide page to rewrite the runner with the things that we have learned in all these years. So that's the goal. What is the status of this runner? This runner is batch only at the moment. It's not in master. It's in a branch, in a feature branch. Why is not in master? Because we want to have at least the validated runner suite passing. So far, we have 88% of the tests passing, and we have work on passing too. But of course, with a new implementation, there are always new surprises, like cryo-serialization issues, and this beautiful thing that the optimizer of Spark showed us here. So this is ongoing work, but it's quickly progressing, so hopefully soon we will master. Just want to mention also here that Etienne Shosho, who is not here, was one of the main contributors on this, so also credits to him. What's ongoing work? Okay, for the structured streaming runner, we have still to implement some things. Support for metrics is not there. Support for state and timers is not there. And of course, the complete support for streaming, that is a bigger task, is also not there. But in that front, I mentioned that test stream transform. That's something that is probably internal to runners, but it's something we need to validate the consistency of the results that a runner calculates, so that would be good to have. On the other front, before we go to master, what we want to have is at least validates runner, and of course, all the integration with the Beam CI, so if there is any error, we catch things, and performance tests. But those are like our things from our side, from the Beam side. But in this work, we discovered many surprises from the Spark side. And the first one was that watermarks are not really aligned between the Spark model and the Beam model. So they're different things. So we cannot map them one-to-one. But more critical is the lack of support for multiple aggregates, and this is a consequence of how the watermark works on Spark. Basically, the watermark in Spark is global, so it's not per operator, and this has this sort of implications. And the third thing we found, and I was really enthusiastic about having continuous processing mode on Beam, on the Spark runner on Beam, was that they only support map-like operations at the moment. So this is like a big surprise for me. And then there are things that we still have to investigate, like how we can map schemas, the Beam schemas into Spark schemas, and if we can benefit of this for the execution plan, hopefully. But looking at the details of this, we found another problem is that this is internal APIs of Spark, because they are improving the optimizers and adding new optimizers. But the API stability is quite changing all the time, so it's not easy to do. So now that's for the two new runners. Now I want to talk a little bit about the Spark runner community. So first I'm going to show some interesting use cases of, doesn't work. Yes. Wow. Well, this thing's not working. Well, there's a video from the JBIF. JBIF is a project of United Nations that is counting all the occurrences, evidence of species around the world. They track like 1.3 billion points. That was a map. Sorry if we cannot see it. That's a really interesting project that is powered by Spark, but the Spark runner, and to integrate many databases of species. Quite cool. I hope someday they come here to present it as a use case. And there is SESNAM also, that is David's company, where they have a web search engine, so they crawl and do all kind of heavy tasks with URLs. This is like this. Okay. And then is Talent. That is where I work. We have this tool to write, to design graphically pipelines. And our most important use of the Spark runner is to be able to support multiple clouds for our clients. So today you can run the Spark runner on top of EMR, thanks to the Spark to this. And soon also we will have this running on top of Azure Databricks. That's the picture of the Spark console on Azure. So if you want to know more about this, well, not exactly the multi-cloud case, but how we use Beam, you can go to Ryan's talk later on. So I also want to give some credit to the people who did the Spark runner, because we wouldn't be there without this effort. So first the Cloudera guys who bring the runner, then the PayPal guys who improved streaming and especially things of real life observability of the runner. Then there was us at Talent who moved the thing into Spark 2 and have been done maintenance since that moment. The SESNAM guys who work in performance and are always bringing good feedback to the runner. Kyle from Google who did the portable runner, and Etienne and Alexei from Talent 2 who are working in the structured streaming runner. As you can see, this effort wouldn't be also possible without companies that have contributed their engineers and time to do this kind of thing. So this is also like a way to thank the people who have contributed to the runner. So what's next? Well, we still have to make easier for users to use the runner. So the one common comment that I heard, even in Berlin Buzzwords 2 days ago too, was that users would like to have more control of parallelism, like they can do in Spark and they cannot do in Beam because of the way Beam is designed. So we're starting to think about how we can do this in a way that is not against the Beam principles, not going to be an easy design problem. But I was optimistic after Lucas' talk on all the metrics that Portability is getting, so we can maybe use those to reprogram the execution plan or something like that. Still to be seen. Of course, we have to make onboarding easier, which implies probably giving up ready-to-use BOM if they use Maven, improving the documentation. And of course, we are bringing all these cases of performance into new tests for the runner. And finally, the support for Spark 3 is something that is also being tracked. If you are interested in that, you can follow that issue. Spark 3 is not yet out, but since these things are breaking changes, we are starting to look it in advance so we can be ready for when it's out. And this is my personal point of view of what would be the ideal future scenario, because of course having 3 runners with different translations like a maintenance nightmare. So ideally we would like to unify all of this. But to unify all of this, we will have to, well, you can see now there the colors of the different translations that they're used. But to unify this, we will first would like to move the portable Spark runner into the structured streaming API. But to do this, well, we have to be sure that the streaming in Spark is good enough to do that. And as you saw with the issues, the open issues, the multiple aggregates, with watermark, etc., probably it's going to be hard. And the second point would be to have the portable structured streaming runner as the only unified runner. But to do that, we have to guarantee that the performance is not really degraded due to all the portability extra things. So this is our dream, but probably will take some time to get there. If you want to be part of this, you can find more information on the Spark runner in that webpage. Don't hesitate to subscribe to the mailing list and join us in the Slack channel. So well, to have more quick response. Thank you, and it's open for questions.
All right, thank you so much for this presentation. We don't have much time, but I would like to open the floor for questions. So raise your hand if you have a question for the speakers, please.
Hi, thanks for the talk. I was wondering, you said you were still looking into the mapping between the Beam schemas and the Spark schemas. You need some kind of schema to use the Spark data frame API. So if you don't do a mapping, how are you currently applying schemas? And would you say that I'm not currently benefiting from using Beam schemas if I'm on the Spark runner? Thanks.
Okay, thank you. No, well, to understand this, probably I should have shown how it works behind the scenes. Actually, in the translation, what we produce is an RDD collection of elements that are called window value elements. So they have a timestamp and window information. So that's what we will probably need to map into Spark. But the problem is that this may produce a hierarchical data. So it would be quite hard for the Spark optimizer to optimize, let's say. And we probably one idea would be to flat this into like a table-like structure, like to be more aligned with the schema. But this is just recently started to be discussed. So let's say we are using the structured streaming API, but the schema is not there. Okay.
All right. Any other questions? We can take one more. Okay, last chance for questions. All right, thank you so much.
Thank you.
Thank you for your presentation. So,
Huh?